Okay, how are you? Today I would like to show you the new method. We call it multi-level thresholding. In this session, I will use Matlab as a software, and what would we do now? The purpose is how the way for us to detect the skin of a human. And the question is, what is multi-level thresholding? Multi-level thresholding is an image segmentation method that use two or more threshold values, and the equation that is used to convert the pixel value of the grayscale image into binary image in the multi-level thresholding method is like this one, where fxy is a grayscale image, gxy is a binary image, t1 is the lower threshold value, and t2 is the upper threshold value. Okay, if we see in this slide an illustration of the change in the pixel values in the multi-level thresholding process is shown in the image below. In this part, as we know that image is like a pixel in the matrix, and the threshold of T1 is 100 and T2 is 150. For this pixel, it will be eliminated because the value of this part is more than 150, and this one also the value is 255, so it must be eliminated. And in this part also it will be eliminated also because the value is less than T1 as a threshold. It is 100. So 12, 46, 0 and 50 will be eliminated also because the value is less than 100. And how to create the segmentation using multi-level thresholding? The following is an example of a digital image processing application along with Matlab programming that I will use now to segment skin color using the multi-level thresholding method. Easily, we can just imagine the step or as follow. The first one is we just simply read the original image, then we convert the image from image color space that was originally in the RGB that we usually use also. We convert it to YCPCR, and then we extract its component of YCP and CR. After that, we can perform multi-level thresholding on CP and CR. And then we have to consider also the number, the value of T1, T2 as the threshold. Some of resources say that for skin we can use T1 threshold is 77 and T2 is 127, and also the upper threshold is carried out with a value of T1 is 133 and T2 is 193. And number 5, we can perform morphological operations that we always use usually in segmentation in the form of filling holes to fill the empty object region. Then number 6 is performing morphological operation in the form of opening area. What does it mean? It means that in this part we can eliminate a noise, the region that is not an object. After that, we can visualize the results of skin segmentation on RGB image, and last we can visualize the results of skin segmentation in the form of a bounding box. On the result, simply I will show you in this image. I use in the film, maybe you know Black Widow. This is one of my favorite film. In this part is the original image, and the figure number 2 is YCPCR, and the last is the result, how the computer vision detect the face as the skin. Now we continue to the Matlab. Okay, obviously as usual we have to save first, of course. Okay, now as usual we have to make sure that our screen can be used properly. So we have to use CLC, then clear the screen, then close all, and also warning for off all. Okay, then as we know, in the first step we have to read the original image. Okay, in this part we just call the image we have by I is image of. Okay, I have file, the name is closed. Close what? Close today. Yes, this one, the most I like. That moment in the Avenger .jpg. Okay, let's see. Are you using this figure and im show I? Okay, let's see first. Okay, for the first step we have done. Then in the second step we have to convert from RGB to YCBCR. Here I will define first as the output is UENT 28, and I will use zeros, and size I is 1, then size I2, and size I, of course, 3, and one more. Okay, now in this step also I will add G and B component of the input image. Okay, I have to define R first. R is from I, and this one, and maybe this one as well. of course one. Okay, just copy it first. G and B, copy command. Still good. Now, after we define all of them, we have to enforce of the average, just of AVG values of the GB using MR is 1 over by mean of R. One more again. Just change for G and B. This for G and B. Then we have to decide the smallest average value using max RGB equals to max MRNN GNMB. Okay. After that, we have to calculate the scaling factor. MR equals to MR over by the max RGB. After that, we have to scale the value that we have for by using out or pada MR. Okay. This of course 2 and 3. This is RG and B. And then convert the image from RGB to YCR CBCR. Okay, using image CBCR is equals to RGB to YCBCR. Okay, then let's see, figure it, then show is image YCBCR. Okay, now we got it. In this result of the conversion, the RGB image to YCBCR, simply actually we can see how it is the skin. The color is a little bit different. Then if we continue it, we have the third step is extracting. The first that we extract is Y from EMG YCBCR. We extract the Y value 1. Okay. Second one is CB, the last is CR, and this 2 and this is 3. Okay, maybe we have to see how the extracted components by using figure, then insert Y. Just copy it. Okay, CP and CR. Let's see. Okay, this is the CR. This is CB component, CR component, and this is the Y component from YCBCR. Okay, the next step is performing multi-level folding. What does it mean? In this part, actually it is the most important part, that we should detect the skin of the human using R, C, and V equals to find when CB is equals or more than, if we see in this part, it is CB, it should be more than 77 until CB 127. So we can just type 77 and CB is less than or equals to 127. And if we see again in this parameter, the CR should be start from 133 to 193. So we can just type here the CR is more than or equals to 133 and CR less than or equals to 193. Okay, then we have to define the num the size is R1. Okay, just say beyond
Wow.
is equals to false.
I need some screwdriver. Thingy. Only one?
Yes, only one.
And this one? Why?
Why? Ah, I don't have.
Oh. Okay, I will check if something is
Oh,
attached with it.
what do you make?
I just attaching my wire. No, it's not. I am attaching my.
Oh, wait. There is no, unfortunately.
Okay, I will check. If not, I will. Okay. Well, meanwhile, I think I don't need it. If I need, I will use it. Gum, glue.
Oh no. Okay, repeat it. So we have to define the bin is equals to false, the size of I is 1 and size is 2. Okay, then we have to mark the skin pixels. Actually we just use for I is equals to 1 and num int and bin r and I ci. Okay, it's equals to 1. Then close it. Okay, and then we try to open it. Figure in so bin. Okay, check it first. Wait. Oh, need one more. Okay. Okay. Now we have done for this step, and we should make it clear. How to make it clear is we can continue to the next step. Performing the morphological, just MO. Just say MO, morphological operation. For this step, actually it is for filling the holes. What is it for? It is for filling the empty object region. To fill empty. Okay. So just say bin equals to infill. The bin we use holes. Okay. Then we try to figure it out. Bin. Okay, let's see the result. Okay, good enough. Then to make it clear, we can use again this number 6 type. We use performing morphological operation also, but different purpose. In this part, we use opening area. What's for? It is for eliminate. For eliminate the noise, of course. So when we can eliminate the noise, we can get the region that is not an object, so we can delete it. Actually, we just use bin, then we use the function of bw area open for opening area, then use the bin and we put how large it is. Maybe I just say 5,000, maybe it is enough, I don't know. Then check it first. Figure install bin, then check it. Okay, maybe the noise is still a lot. I will change to 7,000. Then I will add more, maybe 9,000. Okay, maybe it's good enough. I will check it again later. We can continue to next step. Number 7 is visualizing the result. Okay, how to visualize that result? We can call the R from bin equals to 0, then copy it. RGB, then we define out is equals to CRT 3 RGB, then figure it out again in show out. Then see. Okay. Then we can try to the last step. We can visualize the result in the form of bounding box. In bounding box here I use as region props. I use bounding box, then b box is equals to CAT 1 as bounding box. Okay. After that we call the RGB by RGB is equals to insert shape. I use rectangle here. Rectangle. Okay. B box, and we have to define the line width. Maybe I will use 4 enough, I think. And the last, figure it out again. So RGB and check it. Okay. In this part, we can see how this algorithm to take the human, the skin of course. In this part, the doctor string is detected. In this part, Tony Stark is detected. And this part, the Wong is detected also. If we see in this part, this is the segmentation result. After that, it is shown as the complete image in RGB. Then I put the box. Because I forgot to change the value of MR to be MG and MB, so I have to fix it. MR to be MG and MB now. Then we can check the result. The result is better than what I did before, because in this part I have already fixed it. So you have to pay attention also, because if you forgot to change the value, you will get result But yes, of course you will get the result, but the result is not totally better. So in this scaling part, we have to make sure also based on what we need. Okay, I think this is the last for me. Thanks for your attention. See you again and bye bye.